Hello, my name is Tyler LaBelle, and this is my Chemistry 2 Interactive Advanced Concept Presentation 1. For this experiment, we're going to need a couple of things. We're going to need 2 glasses of water. I have 100 milliliters of water in each one of these containers, table salt, and then some gummy bears. So what we're going to do in this first glass of water, we're going to leave it as is. We're going to have a hypotonic solution here, and I'll explain that a little bit more later on. And then in the second glass, what we're going to do is we're going to completely saturate this with salt, meaning that we cannot dissolve any more salt in the solution. And this will create a hypertonic solution. So I'll go ahead and I will start just stirring some salt in here a little bit at a time. And so you want to stir slowly enough that you make sure that the salt can be dissolved. Now this will take a while, so we're just going to fast forward here a little bit and act like I got it to completely dissolve and that this solution here is completely saturated with salt and no more is dissolving. Now once we have our hypertonic solution and our hypotonic solution, we're going to put gummy bears in each one of these. And then we are going to let them sit for 6 to 8 hours and see what happens. Now, what is going to happen here, if we look at this, where we have a hypotonic solution and a hypertonic solution. In the hypotonic solution, we have a less number of solutes in the water. In a hypertonic solution, we have a higher concentration of solutes. So what's going to happen is the water is going to transfer to the area of higher concentration. It's going to try and equalize the amount of solutes in the container. And this is also known as diffusion. So this happens in our body every day in our cells. So what will happen is before diffusion, we have an area of higher concentration of solutes. Then we have right here a semi-permeable membrane, which are cells, our skin. And then after the diffusion, the solutes will equalize, or the water will equalize. Now, I did this experiment earlier, and here I have a couple of examples. So, this gummy bear here, I know is kind of hard to see because it's clear. I didn't really think that one through. This was in the hypotonic solution. So what happened was, because the inside of the gummy bear has a high concentration of solutes, the water from the glass actually diffused into the gummy bear, causing it to swell. And then if we were to squeeze this, we can see that it's actually very soft, very brittle. It's breaking off in my hand right now, all over the place. And if we continued to leave the gummy bear in a solution for a longer period of time, it would begin to burst. It would burst and then it would fall apart a lot easier than it is. This one is just a standard gummy bear that I did not place in any of the solutions. This was just directly out of the bag. And as we squeeze it, it's not falling apart. It's got some pliability to it, and it's of a decent size when compared to this one that's slimy all over the place, is much larger. Now, this last gummy bear I placed in the hypertonic solution. And as I'm feeling this, it is very dense, it's very hard, there's barely any give to it. So what happened was there's actually less solutes inside the gummy bear than in the hypertonic solution. So the solution itself actually took all the moisture out of the gummy bear and tried to evenly disperse it inside the solution. Now, this is kind of a fun concept, and it's a fun experiment to do because it's not only chemistry, but it's biology. It shows how our cells operate, why blood cells can be shaped a certain way. When a person has a high salt intake in their diet and they have high blood pressure, it could be due to something called crenation, which is exactly what we see here with our gummy bear that was in The hypertonic solution is that the gummy bear actually misshapes, which happens to our red blood cells. So this experiment can be used through to explain several concepts throughout the rest of our lives. So I hope this presentation was helpful, and thank you very much.